The equation we're going to use for the cost of electricity is the cost is equal to the power times the time times the rate. Recall that power is current times voltage and is normally in the unit watts. Well, in the United States, the rate at which electric companies charge consumers is dollars per kilowatt hour. So this is one of those rare circumstances where we won't use the standard SI units in our equation. We need to have the power in kilowatts, the time in hours, and then we can multiply those quantities by the rate to give us the cost in dollars. And this is only because we are charged per kilowatt hour. Let's try an example. A drying oven in a chemistry lab pulls 4 amps and runs constantly. Electricity costs 8 cents per kilowatt hour. Find the cost to run the oven for 1 year. Let's find the power consumed by the oven. The current is 4 amps. We're going to assume that we plug the oven into a standard outlet, which we're supposed to memorize has a 120 volt pressure difference. That's a power of 480 watts. But to use the power in the equation at the top of the screen, we need kilowatts. So 1 kilowatt is 1,000 watts. So I'm going to convert that into kilowatts, 0.48 kilowatts. Similarly, the time needs to be in hours. We're given the time in years. So let's convert years to an approximate number of hours. 365 days is 1 year, and 1 day is 24 hours. Notice how the units cancel nicely. 1 unit in the numerator, another in the denominator. Which means that the number of hours is about 8,760. Now we're ready to use the equation. We need the power in kilowatt hours, the time in hours, and the cost. Notice how the units cancel very nicely. About $340.